simple pulleys. Simple pulleys. Two bodies of masses 21 gram and 28 gram are connected by two ends of a string passing over a smooth small pulley. If the system moves from rest, find the acceleration of the system, the magnitude of the tension in the string, pressure on the pulley, and the velocity of the system after 2 seconds from the beginning of motion. Now we have a pulley and two bodies of masses 21 gram and 28 gram connected by the two ends of a string passing over a smooth small pulley. M1 21 gram, M2 28 gram, and the acceleration gravity equals 980 centimeter per second square, and the system moves from rest, then the initial velocity v node equals 0. What is the equations of motion? Now, with respect to the first mass M1 and the second mass M2, the system moves in the direction M2G downwards. Then M2G minus T equals M2A, equation number 1. And T1, T minus M1G equals M1A, equation number 2. By adding the two equations, we find that M2G minus M1G equals M2A plus M1A. We can substitute 28 times 980 minus 21 times 980 equals 28A plus 21A. 6,860 equals 49A. Then the acceleration A equals 140 centimeter per second squared. Now, to get the magnitude of the tension, we can substitution in equation number 2. Equation number 2, T minus 21 times 980 equals 21 times the magnitude of the acceleration, 140 centimeter per second square. Then the tension equals 23,520 dyne. Now, the tension equal 23,520 dyne divided 980, then the unit is gram weight, and the tension equals 24 gram weight. What is the pressure on the pulley? The pressure P in this case equals 2T, twice the tension in the string. Then P equals 23,520 times 2, which equals 47,040 dyne. Or P equals 2 times 24 gram weight, then P equals 48 gram weight. Now we can calculate the velocity of the system after 2 seconds from the relation V equals V naught plus AT. Then V equals 0 plus 140 times 2. Then the velocity after 2 seconds from the beginning of the motion equals 280 centimeter per second. Another example. Two bodies of masses 105 gram and 70 gram are connected by the two ends of a light string of constant length passing over a smooth small pulley and suspended vertically. If the system starts to move from rest when the two masses are on one horizontal plane, find the magnitude of the acceleration of motion of the system. If the first body is impinged against the ground after it traveled 50 centimeter, find the total time taken by the second body from the beginning of motion until it come to rest. Now we have two masses, M1 105 gram, M2 equal 70 gram, and G equals 900 centimeter per second square, and the system at rest. Then the velocity V node equals 0, and the system moves 50 centimeter. Then S equals 50 centimeter. We know that M1 bigger than M2, then the motion in the direction of the first mass M1, and the equations of motion are M1G minus T equals M1A, equation number 1. The second equation, T minus M2G equals M2A, equation number 2. We can solve the two equations by adding the two equations. Now, M1G minus M2G equals M1A plus M2A. Then 105 times 980 minus 70 times 980 equals 105A plus 70A. Then 34,300 equal 175A. Then the acceleration of motion equals 196 centimeter power 2. At the moment of the first body impinges against the ground, it takes time, let it T1. Then V squared equals V naught square plus 2AS. The initial velocity equals 0 and the acceleration 196 centimeter, and the distance equal 50 centimeter. Then V equals 140 centimeter per second. What is the time taken in this case? V equal V naught plus AT. Then 140 equals 0 plus 196t. Then the time equals 5/7 seconds. Now, when the first body impinges against the ground, the second body moves vertically upward with acceleration G. Then it's beginning with velocity, initial velocity V naught equal 140 centimeter per second, to come to rest after time T2. Then V equals V naught minus GT, and the final velocity 0, and the initial velocity 140 centimeter per second minus 980t. Then the second time T2 equals 1/7 second. Then the total time taken by the second body from the beginning of motion until it come to rest equals T1 plus T2, which equals 5/7 plus 1/7 equals 6/7 second. Then the first body impinges to the ground, and the second body is start to move upward after that. Then the total time equals 6/7 seconds. Another example. A body of mass 45 gram is placed on a horizontal table and is connected by a string whose other end is connected by a body of 4 gram suspended vertically, and the string passes over a smooth pulley at the edge of the table. Find the common acceleration for the system, the tension in the string, and the pressure on the pulley. Now we have a body of mass 45 gram, M1, placed on a horizontal table and is connected by a string whose other end is connected by a body of mass 4 gram. We know that G equals 980 centimeter per second squared, and system is beginning to move. Then the equations of motion are M2G minus T equals M2A, because the body M2 moves downward, vertically downward, with acceleration A. And the body in the table moves under the action of the tension in the string T. Then T equals M1A, the second equation. Now we have two equations. By adding the two equations, we find that M2G equals M2A plus M1A. M2, the mass of the second body, 4 gram times 980 equals 4A plus M1, which equals 45A. Then 3920 equals 49A. Then the acceleration of motion equals 80 centimeter per second square. The acceleration here is the acceleration or common acceleration for the system or for the two bodies. Now, to get the tension in the string, we can substitution in equation number 2. The tension T equals 45 times 80, which equals 3,600 dyne, and we can convert this value to gram weight by divided by 980. Then the tension equals 180 over 49 gram weight. Now, what is the pressure in the second case? The pressure on the pulley when the pulley at the edge of the table equals root 2 times the tension T. Then P equals 3,600 root 2 dyne, or P equals 180 root 2 over 49 gram weight. Another example, a body of mass 60 gram is placed on a rough horizontal table, then connected by a string passing over a smooth pulley at the edge of the plane, and the body of mass 38 gram is connected by the other end of the string. If the system moves from rest to travel a distance of 70 centimeter in 1 second, calculate the coefficient of friction if the string is cut at this moment. Calculate the distance which the first mass moves after that on the plane until it rests. Now we have a rough horizontal table. Then the friction force mu Kn is act on the body in the opposite direction of its motion. The body M1 equals 60 gram is placed on a rough horizontal table, and the second body M2 equals 38 gram, and the acceleration G equals 980 centimeter per second squared, and the system starts motion from rest, then V naught equals 0, and travel a distance of 70 centimeter, then S equal 70 centimeter in 1 second, the time T equal 1 second. Now S equal V naught T plus half AT squared, then 70 equals 0 plus half times A times 1 power 2. The acceleration of motion A equals 140 centimeter per second squared, and N equals M1G. N is the magnitude of the normal reaction of the plane of the body. N equal M1 60 times G 980, then N equals 58,800 dyne. Now what is the equation of motions of the system? The equations of motion are: the first equation, M2G minus T equals M2A. M2G minus the tension in the string equals M2A. About the body on the table, the tension T minus mu Kn equals M1A. Now, by solving the two equations, by adding the two equations, we find that M2G minus mu Kn equals M2A plus M1A. M2 38 times 980 minus mu k times the magnitude of the normal reaction 58 and 800 dyne 58,800 dyne equal 38 times A plus 60A. Then 37,240 minus mu k times 58,800 equals 98 times 140. Then the coefficient of friction mu k equals 2/5. At the moment the string is cut, then V equal V naught plus AT. V, the velocity, equals the initial velocity 0 plus 140 times 1. Then the velocity of the system at the moment of the string is cut equals 140 centimeter per second. After the string is cut, the mass 60 gram moves with deceleration on the rough plane until it rests. Deceleration meaning the velocity decrease until it comes to rest or the velocity equals 0. Then we have the equation of motion of the body on the table. The tension equals 0 because the string is cut. Then the equation is negative mu kn equals m1a dash. Mu equals 2/5 times n equals 58,800 equals m1, which equals 60 gram times a dash, the acceleration of motion. A dash equals negative 392 centimeter per second squared. Then now we get the distance which the first mass moves after that on the plane until it rests from the relation V squared equals V naught square minus 2gs. 0 equal 140 power 2 minus 2 times negative 392s. Then the distance s equal 390 centimeter. Another example. A body of mass 3 kg is placed at the lowest point of a smooth inclined plane of length 210 cm and height 140 cm. This body is connected with another body of mass 4 kg by a string of length 210 cm. The string coincident to the line of the greatest slope of the plane and the other end is suspended at the upper edge of the plane. If the system starts to move from rest until the greatest mass reaches the ground and gets at rest. Find the distance which the small mass moves on the plane before it stops, supposing that its motion is not acted as the greater mass impinges against the ground. Now we have inclined plane, inclined to the horizontal with an angle of measure theta, and a mass 3 kg is placed at the lowest point of the smooth inclined plane. Smooth inclined plane means there is no friction force. M1 equals 3 kg and M2 equals 4 kg and G equals 9.8 meter per second squared, and the system starts from rest, then V naught equal 0 and travel distance S equal 0, then M2G equals 4 times 9.8 equal 39.2 Newton. And M1G sin theta equal 3 times 9.8 times 140 over 210. Then M1G sin theta equals 19.6 Newton. And we know that M2G, which equals 39.2, is bigger than m1g sine theta, which equals 19.6 Newton, and the direction of motion as shown in the opposite figure, and the equations of motion are: the first equation, m2g minus t equals m2a, and the second equation, t minus m1g sine theta equals m1a, equation number 2. By adding the two equations, we find that m2g minus m1g sine theta equals m2a plus m1a. Then 4 times 9.8 minus 3 times 9.8 times 2 over 3. 2 over 3 is the sine of angle of inclination, equals 4a plus 3a. Then 19.6 equals 7a. Then the acceleration of motion equals 2.8 meter per second squared. Now calculate the velocity of the body of mass 4 kilogram to reach the ground. V squared equal V naught squared minus 2gs, and V squared equals 0 plus 2 times 2.8 times 1.4. Then the velocity equals 2.8 meter per second. After the body of mass 4 kilogram reaches the ground, the body of mass 3 kilogram moves on the plane with deceleration, and the equation of motion of this body moving on the inclined plane is negative m1g sine theta equals m1a. Then negative 3 times 9.8 times 2 over 3 equals 3a dash. A dash is the magnitude of the acceleration, equals negative 98 over 15 meter per second square, and this acceleration is negative, then the velocity decrease. And we can find the distance which the body moves on the plane until it rests from the relation v power 2 equals v naught power 2 plus 2a dash s. 0 equals 2.8 all power 2 plus 2 times negative 98 over 15 s. And s equals 0.6 meter. Now, what is the distance or the total distance the body traveled? S equals the total distance 1.4 plus 0.6 equals 2 meter. Then the mass 3 kilogram come to rest at a distance of 2 meters from the base of the inclined plane. Another example, a body of mass 1 kilogram is placed on a rough inclined plane inclines to the horizontal with an angle of measure theta, where sine theta equals 1 over 3, and coefficient of kinetic friction between the body and the plane is equal to root 2 over 2. The body is connected by a string coincident on the line of the greatest slope of the plane and passes over a smooth pulley at the top of the plane, suspended vertically to carry a body of mass 3 kilogram in its end. Find the pressure on the axis of the pulley if the system starts to move from rest and after the mass 1 kilogram travels a distance of 1.8 meters on the plane. The string connecting the two masses is cut. Find the total distance which the mass 1 kilogram traveled on the plane before it come to rest. Now we have m1 equals 1 kilogram, m2 equals 3 kilogram, g equal 9.8 meter per second square, and the system starts from rest, then v naught equals 0. Travel distance 1.8 meter, and mu k equals root 2 over 2. Sine theta equals 1 over 3. Now M2G equals 3 times 9.8 equals 29.4 Newton, and M1G sine theta equals 49 over 15 Newton. Then M2G bigger than M1G sine theta. Now, the direction of motion as shown in the opposite figure. Then N equals M1G cosine theta, which equals 1 times 9.8 times 2 root 2 over 3. Then N equals 98 root 2 over 15 Newton. And the equations of motion are: equation number 1, M2G minus T equal M2A, and equation number 2, T minus M1G sine theta minus mu Kn equals M1A. By adding the two equations, we find that M2G minus M1G sine theta minus mu Kn equals M2A plus M1A. Then 3 times 9.8 minus 1 times 9.8 times third minus root 2 over 2 times 98 root 2 over 15 equals 3A plus 1A. Then 19.6 equals 4A. The acceleration of motion A equals 4.9 meter per second squared. Now, to get the tension T, we can substitution in equation number 1. Then the tension T equals 3 times 9.8 minus 3 times 4.9 equals 14.7 Newton. And the pressure in this case, in case the pulley fixed at the edge of inclined plane, the P pressure equals T square root 2 times between two bracket 1 plus sine theta. Then the pressure equals 14.7 root 2 times 1 plus 1 over 3 equals 49 root 6 over 5 نيوتن. بكده أعزائي نكون استعرضنا مع بعض موضوع سيمبل بوليز، وعرفنا الكيسز المختلفة ليها، وعرفنا ازاي نحسب الاكسلريشن، التنشن، البريشر اون ذا بولي في الحالات الثلاثة، وعرفنا ازاي نستنتج الايكويشنز اوف موشن في كل حالة من الحالات الثلاثة. Dear students of grade 3 secondary, by this example we come to the end of our program today. Till we meet again, it's goodbye.